Hello everyone, and welcome to today's SANS webcast. Obfuscated no more. Practical steps for defeating Android obfuscation. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Joshua Wright, Senior Technical Analyst with CounterHack. If during the webcast you have any questions for Joshua, please enter them into the questions window located on the GoToWebinar interface. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Josh.
Thank you so much, Carol, and thanks everybody for joining us today on the webcast. So I came up with the idea for this webcast because as the author of the SANS Mobile Device Security and Ethical Hacking course, I've been spending some time updating course material. As SANS authors, we're always updating course material, and I've been writing this material that I'm really super excited about. And it's based off of a lot of my experiences doing customer work and doing penetration tests, but also as an Android developer, the things I'm learning that work and the things that I'm learning that don't work from a defensive and security perspective. And I wanted to share some of this new material with you here today. And one of the things that I'm really excited about is some of the new techniques that I've been applying to overcome the problem of obfuscated Android applications. So my goal today is to help you understand what's involved with Android obfuscation, to get some concrete examples of what it looks like and what you might experience as a mobile security analyst when you encounter an application that's using obfuscation, and then specifically some techniques to get around and to defeat those mechanisms as well. So my goal and my plan here is to spend some time looking at a couple of slides here just to kind of get the ball rolling, but I really want to spend most of this webcast demonstrating different tools and techniques, so I'll flip back and forth as we're going through. So at CounterHack, we build Net Wars. If folks have seen the Net Wars platform before, we build the Holiday Hack Challenge every year, and last year's Holiday Hack Challenge we started doing a lot more focus on mobile applications. And if you've played our Holiday Hack Challenge, you know what I'm talking about. If you haven't seen it, you can just Google Holiday Hack Challenge. It will be the first hit. And it's a free online hacking challenge that we make available to the community, and then we just run it in perpetuity, just so people can use it. If you've never played before, it's a full role-playing game with little like Zelda-like characters on the screen, and also hacking challenges. And a big part of it this year was mobile application analysis. And so in the mobile application for this year's challenge, we had an application called Santagram, and it's like an Instagram clone for the North Pole, for elves and for Santa. And you needed to reverse engineer the application and analyze it. Well, I've been working more and more dealing with applications where Android developers are trying to stop people from trying to understand what's really going on behind the scenes in the application. At CounterHack, we do consulting work as well, and so customers will bring us their Android, their iOS applications, and they'll want us to evaluate them from a security perspective. And one of the things that we do in those tests is we look at the application in a reverse engineering perspective, where we take the app and then we try to reverse engineer it to understand what's really going on behind the scenes. This is something that you will need to do as a mobile security analyst. Today I'm going to focus on Android applications. Certainly this can apply to iOS applications as well, and maybe that's the topic for a future webcast. iOS reverse engineering is much harder, but we're going to focus on the Android perspective today. Okay, I want to just start with a little bit of a warning here, just so everybody coming into this knows what's going to happen. There's going to be code ahead. You're going to see code showing up here, and I don't assume that you're a programmer. Even in my classes, I don't assume that you're a programmer, but I've got a couple of assumptions about you. One, that you're pretty smart. And if you're interested in something as esoteric as de-obfuscating Android applications for better reverse engineering, I'm thinking that you're a pretty smart guy or a pretty smart girl. And my second guess here is that you can Google stuff that you don't understand. even if you're not a programmer, you're going to have to look at code when we're doing reverse engineering of Android applications. Now, I want to let you in on a professional secret. Real programmers, the people that do nothing but code on a regular basis from 9 to 5, or if you're in California, from 12 p.m. to 8 p.m., they go to Stack Overflow about 200 times a day. They're constantly Googling things that they don't know, looking for code examples, looking for information that will be useful to them. You should also use that same trade secret. I Google code that I don't understand. I have to look at developer.android.com very, very frequently just to try to understand what's involved with everything that's going on. Even if you don't know Java, the programming language that we use for Android applications, you can still Google things you don't understand and pick it up pretty quickly. Today we're going to be looking at code, but don't try to get overwhelmed by the fact that if this is code that we're looking at. It's not that difficult, and I'm going to give you some hints and tips as we go through here. Okay, so we're going to be talking about Android application obfuscation, and I'm going to switch right to demo mode here, okay? And so I'm presenting from my Mac, but I'm using VMware Fusion, and I've got a Windows 10 virtual machine. I'm going to show you as much of the techniques as I can from Windows, because I think that's what most people are using. All of the techniques that I'm showing you will also work from a Mac, and I'll show you the things that don't work on Windows but will work on Linux or Mac when we get to that part of the presentation. So I'm going to look at several tools and several techniques here today, and what we're going to do is we're going to reverse engineer some of these Android packages. Now, I do want to share a couple of notes with you here. So I've got a couple of links that I'll paste into the chat as well, so everybody gets these links. Okay. So one question you might ask is, Josh, where do we get these Android application packages, these APK files? Well, there's a couple of ways we can get these APK files. I get APKs from the website APK Monk or APK Pure frequently. You don't need an account. You go to the website, you type in the name, and if it's a free application, you'll be able to download the APK. Now, otherwise, if I'm on a pen test or I'm doing a customer engagement, I ask them to send me the APK. Sometimes I'm doing testing before it's publicly available, so I'll coordinate that. I'm not asking for source code, just the application package, what every user will get when they install the application. Now, if it's an application you have to pay for that you have to reverse engineer, then I'll just use an Android Nexus tablet or a Samsung device that I have available, and I'll download and install it just like a normal user would. On my Android devices, I have several rooted Android devices, and then I'll use that root level access to then get the APK file and copy it right to my Mac or from my Windows system. So we're starting with having one of these APK files here to work from. And we're going to look at a couple of applications in this webcast today, one of which is an application I wrote called Digital Wallet. Now, I've got two versions of Digital Wallet here on my Windows VM, one that's obfuscated and one that's not obfuscated. And I'm going to show you what the difference is between these two applications. Now, before we look at those differences, I have to talk about another tool here called Jadx. And I'm going to give you this link in the notes section here. Jadx is a free tool by Skylot, and it's a fabulous reverse engineering tool for Android or Java applications. Now, the old school technique for reverse engineering an Android app is to take the APK file, convert it to a Java jar file by using a utility called dex2jar. That's dex2jar. And then opening up that jar file in a reverse engineering tool. Typically the tool that people use is JD-GUI for this. Now, I'm here to tell you to stop doing that. Dex2jar, JD-GUI, they were wonderful tools in their heyday, but they've largely been surpassed with Jadx. Jadx is a far superior reverse engineering tool. There's no conversion process. It does not suffer from a lot of the bugs present in Dex2jar and JD-GUI. And it's got a lot of tremendously powerful capabilities that we're going to look at and demonstrate here in this presentation today. So on my Windows system, I've already got the GUI version installed on my system. So I'm going to run Jadx GUI. And when you run Jadx GUI, it asks you to open an APK file. And I'm going to open an APK file from my desktop directory here. And I'm going to open my digital wallet application in non-obfuscated mode. So I wrote the app, I have the source code, so I compiled it for demonstration purposes here in non-obfuscation mode to start with. And this is what Jadx looks like. I'm going to move it over to the right here and just try to fill the screen a little bit. So with Jadx, we open the APK file and it will decompile the application on the fly for us, taking that APK file and turning it into a representation of the Java source code. Now, if you're a developer writing Android applications and you compile it using Android Studio or other tools, this is what the app will look like when it's decompiled. When I decompile the application, I see that there's a couple of packages. These little brown things are packages, Android support, and com.willhackforsushi.digitalwallet. Within the digital wallet package, there's several classes. There's main activity, which is the entry point to the application, and when I click on it, it will decompile it and show me the source code for the application. Now, this is an inherent problem in Android applications. Because Android platforms support so many processor types, developers can't be expected to compile their application for each CPU type when they distribute the app. Instead, Android applications are very much like Java applications, where the developer writes the application in Java source and compiles it into an intermediate bytecode format. That intermediate bytecode format is then converted to native instructions when you install or when you launch the application, depending on your version of Android, and then it's stored in the low-level machine code. But when we download the app from APK Monk or APK Pure, or we get it from a rooted Android device, we get the original APK version, which shows us this Android source information. So normally what happens when we're evaluating an Android application, we'll open it up in Jadx, and then we'll start looking at the source code. And clearly some password information is jumping up at us here. We see there's some AES encryption operations going on here. There's a whole crypto class with a whole bunch of stuff going on in here. And what we'll do is we'll just try to understand this reconstructed Java code to see what is actually going on in the application. Now, clearly, this is a problem for app developers. App developers don't want us to look at this level of source code from their applications. So what a developer will do is, if they're savvy, they will obfuscate their application, where they will compile the application and they'll turn on one or more obfuscators, which changes the application so that when the decompiler looks at it, they don't get this native Java source. Let me show you what that looks like. I'm going to open another command window here, go to my directory where I've got all my applications, and this time I'm going to run Jadx GUI, but instead of opening from the file dialog, I'm just going to open it right from the command line here by specifying the APK file as a command line argument. On the right, I've got the unobfuscated version, and on the left side here, I have the obfuscated version of the application. And what happens when we open the obfuscated version of the application? Notice how most of the application classes don't preserve the original names, where before we had AES CBC with integrity, we had build config, we had a crypto class. Now, although we have some names that are preserved here because they're entry points for the application, a lot of the application functionality is renamed to things like Class A or Class B. And then within Class B, instead of an actual method name that makes sense, now we've got method B. And then we have variables that don't make a lot of sense as well. OBJ, bvar. When a developer obfuscates an application, it turns it into this very legible version, AES key length bits equals 128, into things that look a lot more like this. I think D is what I'm interested in. Yeah, so now instead of an actual name that makes sense, variables are called A, B, methods are called A, B, things like that. So, and then we get things that look like com.willhackforsushi.digitalwallet.d.b.b for the variable B, and so on. Obfuscation at its fundamental level renames everything that can be renamed into things that don't actually make any sense. Now, if you're reverse engineering an Android app and it's not obfuscated, that's a wonderful thing. And it's very easy to open up the source in Jadx GUI and start looking at the code. But if it's obfuscated, like we see here, then it becomes much more complicated and much more time-consuming to understand what's going on within the application itself. So, the tool that I use to obfuscate that digital wallet application is called ProGuard. And ProGuard is built into Android Studio. It's very, very popular among Android developers because all they have to do is change a configuration file, and then every time they build the app, it gets built in obfuscated mode, which makes it much harder on the developer to try to understand what's going on. Here, like I showed you in the demo, we have all the application functions, but instead of append hex, decrypt, encrypt from hex, we've got things like A, C. Look, another thing called A, because they overload these classes so they don't collide. But it becomes very confusing for us to understand that, and it makes understanding the application from a reverse engineering perspective much, much harder. Okay, now there's a couple important things to point out here. When an application does obfuscation, it can obfuscate some things, but it can't obfuscate everything. So what can get obfuscated with a tool like ProGuard? Anything the developer names, including a class name, a method name, which is like a function inside of a class, or a variable itself. Now, what's important is what can't get obfuscated. For example, third-party libraries that are shipped with an Android application that are distributed in a binary form can't be renamed because the source code is not available. So this is very important to us because it gives us an opportunity to still see what's going on behind the scenes in an application. No Android app will ever be 100% obfuscated. There's always little pieces for us to latch onto. And sometimes we have to go through a lot of trouble to de-obfuscate an application, but it certainly can be done. No obfuscation method is perfect. There's always an opportunity for the developer to de-obfuscate and to reverse engineer an Android application. Okay. So we looked at some examples of obfuscation sources here, and what I wanted to talk to you about today specifically is how to overcome some of these obfuscation mechanisms. Now, one thing we could do, if I go back to my demo here, if we're focusing on the obfuscated Android application here, we could just tough it out. You know, we might say, look, this does not make a lot of sense, but if I have a notebook, like a notepad, a pen, and a lot of time on my hands, I could go in and start documenting this. And I could write on my notepad, okay, this is com.willhackforsushi.digitalwallet.d, and then we look at, let's see, the B class right here, okay, so the B method right here, and we can say, okay, synchronized B, what is B? Well, we have to come up here to say, okay, what is B? B is some kind of an object, okay, I don't really know what that means yet, but we can keep going here, and we can say, okay, synchronized, oops, what is it? Synchronized on B if D, okay, D is something else. So what's D? We're going to go back up here, and okay, D is an output stream object. We could tough it out like that. And you could spend a lot of time trying to understand the code, taking copious notes, and going through just this Jadx GUI interface to try to understand what's going on in the application. You could do that, but you're going to hate it really quickly because the obfuscated code does not make sense, and you're going to keep flipping back and forth. Okay, well, was that D in this object or D in that object? Okay, was it D.D.C or was it D.C.D? It's going to become very confusing very quickly to try to tough it out and to try to decode the application right from Jadx here. This is where obfuscation really shines, where if I have the application open here, in the non-obfuscated form, I could just, look at the crypto decrypt activity mechanism here, and I can read this code, and it makes sense to me, and it's fairly legible. In the obfuscated version, not so much. It's very difficult to understand and read this functionality, which is the whole point of why a developer will obfuscate an application. So that's option one. You could tough it out with Jadx, but that's going to get old really fast. Option two, however, is what I want to talk to you about today, and that's taking the decompiled code, or what we like to call the reconstructed code from Jadx, and then to annotate it, to try to understand what's going on inside the application itself. Now, unfortunately, Jadx is not really designed for this. If I decide that this Boolean is something that controls synchronization, I might, want to rename it, but I can't. Jadx doesn't allow me to, add a comment, nothing. Jadx is not designed to help you annotate or rename or understand what's going on inside of an obfuscated application. It's just not. It shows you this representation of it. It's very powerful, but it's not really well suited to understanding obfuscated applications. However, I'm going to show you a way to combine different tools together that will give us a very powerful perspective about what's going on. Just while I'm going through the presentation here, if you guys have questions, go ahead and enter them in that chat window. I'm going to check it at the end of the presentation and answer any questions you guys have. But don't wait, because I don't want you to forget an important question you wanted to ask. Go ahead and enter it in that chat window, and then I'll answer those questions at the end of the presentation. So I'm going to exit Jadx here, and I'm going to continue working from my directory with the applications. And I'm interested in understanding what's going on in this APK, the digital wallet obfuscated version. Jadx comes with a GUI interface, which you've already seen, which allows us to click our way through and read the source code for an application. But it also comes with a command line tool. The command line tool is not an interactive mechanism. What it does is it takes an APK file, it decompiles everything inside the application, and it spits it out into a directory you specify. Now, you can also do that from the GUI. You can say file, save all as sources, but what I'll typically do when I know I'm looking at an obfuscated application is I'll create a temporary directory, make dir, digital wallet. I'm just going to close Twitter here. And then I'll say Jadx, instead of Jadx GUI, just Jadx, -d digital wallet, save all the decompiled sources into this directory, and then I give it the obfuscated APK file to process. Now, this is going to generate a ton of output. And Jadx is not perfect, and it will get errors every now and then, but you'll notice that most of these errors are not in the com.willhackforsushi class. It's in the android.support or the android.support package. So most of these errors are not really concerning to me, because I'm mostly concerned not about a third-party library that's in the application here, but with the application itself, com.willhackforsushi.digitalwallet. Now if I do a dir, I see my digital wallet directory, so I'm going to cd to that directory. And if I do a dir here, I can see the reconstructed source code directory. I see things like the Android manifest file, which I can type out here. And the Android manifest file defines for me things like permissions the application uses. It also identifies things like activities. An activity in Android is just a string. Okay, so you see an activity here. An activity is just not a string. It's a screen, like what you would see like a window inside of an application. It says that there is an activity called com.willhackforsushi.digitalwallet.decrypt activity. There's also one, again here, another activity, but it's called com.willhackforsushi.digitalwallet.main activity. So by looking at this Android manifest file, I can see some interesting endpoints that I'm interested in looking at here. Android, if we look back at the directory structure, is that third-party library, which I'm not concerned about. REST is where you'll find graphics or audio files or XML files that support the application. But what we're interested in is the directory tree starting with the package name. So here it's com willhackforsushi digital wallet. And now we see this reconstructed source code. Now, this source code here is just what we saw in Jadx GUI. But instead of only accessible from the GUI, it's available to us in an editable format. Now this is nice because I can say, remember that variable that we were looking at earlier, this output stream? Now, we can add comments. We can say, we can add comments, things like that. But even here in Notepad, it's not really a great interface because we're only making small changes about what's going on. I don't use Notepad for annotating. What I do is I use Android Studio. Now, Android Studio is available at developer.android.com. And it's a free tool that's available. It comes with the Android emulator. It's a pretty big download, but it gives us and developers an IDE, an integrated development environment with which to write Android code. I'm going to start Android Studio. This is my first time running on Windows, so it's going to ask me about importing old projects. Setup wizard. I don't really need it to download all these things. I just want to get to this main window here. Now, one of the great things about Android Studio is that it can import projects. And one of the great things about Jadx is that the export format from Jadx will import right into Android Studio. So from Android Studio, I'm going to say import project. I'm going to go to the directory that I just created with Jadx called Digital Wallet, and I'm going to say OK. And I'm going to go through this wizard, and literally, I have not read these wizard steps in so long. All I do is say next, 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 finish. Oops. Maybe I should read those prompts. Let's see. Import project, digital wallet. So this is what happens when you do a live demo. A friend of mine told me once, Josh, whenever you're doing a live demo, say nothing about what it is you plan to do in the demo other than watch this. And then whatever you wanted to have happen in the demo is exactly the thing that you wanted. Okay, I'm not sure why it didn't work the first time. The second time, I literally did not change any options. I just said next, 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 finish, and here we go. So I don't know why I broke the first time, but this is what I wanted to show you. By importing those sources into Android Studio, now we can navigate them in this full IDE that the Android project makes available to us, okay? Now, I've not done some things like I've not defined a project SDK because I don't think I have it installed on Windows right now. But the reason this is so useful for us is because now we get color coding and we can look through and identify what's going on inside the application. We can click our way through and evaluate the functionality of the application just by using the IDE like any developer might do. Now, again, I don't assume you're an Android developer. Maybe you've never seen the Android Studio IDE before, but I'm going to show you several tips on how you can go from this obfuscated source to de-obfuscated sources. Okay? So just to show you these slides really quick, importing from Android Studio, exporting, okay? And this is what the imported code looks like. Here are several tips on what we can do to go from obfuscated application to de-obfuscated application. And the first tip is to use strings. A lot of applications will have strings, or just constant collections of characters that are printable, that give us some insight into what's going on inside the application. So here, for example, I don't know what A is, because the obfuscator renamed whatever the developer called it to A, but I know it's a file object. And I know the file object is being initialized with /dev/urandom as a string. Now on Linux, dev/urandom is the random device, okay, for getting random data. So I don't know what the original developer called A, but looking at that line of code, it makes sense to me that A could be called random file object, okay? So what we can do in Android Studio is highlight the variable name A that we want to rename here, and I'm going to right-click, I'm going to choose Refactor, and I'm going to go to Rename. And it gives me the opportunity to now rename that variable. And what I'm going to do is I'm going to rename it to urandom file object. Now, why did I right-click and refactor as opposed to just typing over the name there? Here's why. Notice how when I rename it here, it renamed it in all of these other locations as well. That's the power of refactoring in Android Studio. By renaming that one variable where I understand what it means, it will also rename all of the other instances of that variable as well. When I press enter, now they're all renamed, not just the 4 on this screen, but wherever they exist or are referenced inside the application itself. Now, this is tremendously powerful to me because I don't have to understand all of this source code. All I have to do is understand small pieces of the source code, and as I look through those pieces, rename things so they're more sensible to me. Now, I've talked to a lot of students about reverse engineering, and I find that people approach reverse engineering with the wrong kind of methodology, the wrong mindset. People look at reverse engineering of an application, and that's for Android or anything else, with I need to understand what's going on in this application as a whole. That's the wrong approach. A much more reasonable and attainable approach is to say, I want to understand this one line of code or this one block of instructions. I want to understand tiny pieces of the code's functionality at a time. And by understanding tiny pieces, another tiny piece, another tiny piece, you build a grander understanding of the application. Don't jump into an app and say, I need to understand what this app does. jump into an app and say, what can I understand a little bit at a time? Okay, so here, for example, okay, this is an exception here, okay, in the string failed to read from urandom file object, okay? Now, this throwable E here is just something called an exception. So I can, again, refactor and rename that, and we can call it urandom file object exception. And that doesn't do a lot for me, but as we do more and more of that in the application, this will become more and more legible to us for analyzing what's actually going on. Okay? So that was concept number one. Use strings in the application to understand what's going on. Refactor and rename, and do that throughout the application to understand things that are going on. Here's tip two. Use complex types. And so this is the Digital Wallet D Secure Random SPI. So let me get to that. Okay, so here's another class, okay, called D, and it extends something called Secure Random SPI, which is used for initializing random number objects. Now, if we look at this code, we see that this file object has already been renamed, because I renamed it down here. That's the urandom file object. But I see some other variables here. This data input stream is called C. That output stream is called D. Now, the problem with obfuscation is that C, D, A, B, you're going to see those names over and over and over again, and this has become very tedious because you won't be able to, off the top of your head, differentiate one class's A object from another class's A object. So we want to rename them to things that make sense for us. Now, another thing that we could do, I don't see a string or anything about this data input stream object that's called C here, but I know that it's a data input stream object. Now, these are what we call complex types in Java or in Android. A complex type is something that's a variable that's not simple. A simple variable would be like a string or a byte or an integer, but there's complex variables like data input stream or an output stream. Now, I know that this is associated with the random file object, so I can say, oh, this is some kind of object. I'm going to right-click, refactor, rename again, and I'm going to call it just data input object. Oops, not that one. Data input stream, that's what I wanted. Refactor, rename, data input stream. Now notice how capital D in data input stream is reserved for the type, lowercase d is fine. So all I did was rename that variable C to data input stream, lowercase initial letter. I can also do the same here. Shift F6 does the same thing as right-click, refactor, rename. And when you end up doing it a lot, you're going to want to know those keyboard shortcuts. So I highlighted it and I press Shift F6, and I'm going to call it output stream. Now, as I go through and rename those variables, I will get more and more information about what's going on inside of the application, okay? So now, that formerly variable called C is now referred to here as com.willhackersushi.digitalwallet.d.data input stream. Now, it doesn't help me tremendously, but every little bit helps a little bit. And as we do more and more of that refactoring and renaming, the application becomes more intuitive and more understandable to us. So that's tip number 2. Use those complex object types, whether they be Booleans, data input stream, output stream, things like that, okay? Rename them to the object type name, just make the initial character a lowercase, or add a number to the end, or add something to the end. Data input stream near random file object. That's fine, as long as it gives you a little hint about what's going on. Add your own comments. So as you start renaming things and you see what's going on, you can annotate just like a developer will do. So a synchronized block is used for things like threading, and I've just added a little description, / to start a comment, and then I add synchronized block, maybe threading for dev-urandom object, because I see it's associated with that random file object. That's probably what's going on here. So I can even, again, rename this. Oops. Rename that to sync object dev-urandom. Okay. And as I go through, I'm making the code more and more legible, always starting with these little pieces, but building my understanding about what's going on. So tip 3, add your own comments. Okay? Now, another thing I find myself doing a lot, and this is in the this B object right here. Oh, I just renamed it. But what I will often do is I'll say, okay, if I'm looking at this method called B, and okay, so here's my output stream, here's the synchronized sync object dev-urandom I just created, and then there's a variable called D. I don't know what D is. It's not even declared inside of this method, so it must be a class or maybe a global level variable, I'm not sure. So what I'll often do is I'll highlight, right-click, go to declaration, and you can see that that's Control B down here. When you go to the declaration, it'll jump right to where that reference is. And now I can hop back and forth. Don't try to find something called D. You'll never find it because there's a million things called D. But if I go to the declaration, then it will jump right to the specific instance that I'm interested in, and then I can kind of backtrack my way from there. So the go to declaration function in Android Studio is really useful as well. Another great one is logging. Okay. Now this is really useful. Let's look at this. This is in Android Support v4 App V. So I'm going to go to Android Support v4 App V. And notice here how there are logging statements. Developers will use logging frequently inside of their applications just for their own troubleshooting and analysis functionality here. So here, the method is called A. So I don't really know what the method does, but the logging statement has 2 arguments. The first is a string that identifies usually a tag or some kind of identifier for the logging message, and then the logging message itself. Well, what most programmers do with logging is they make that tag, that first argument, the name of the method that raised the logging message. So here, even though the method has been renamed to A by the obfuscator, the developer left this little clue that it's actually something called fragment manager. Again, Shift F6, and I'll rename it to fragment manager. Now, that particular method is used in a whole bunch of locations. So I can select all of them, and then I can say OK, and it will search for and rename all those variables. If the refactor rename is just in the class that you're looking at or the package that you're looking at, it'll just rename it. If it's extending beyond multiple classes, it will give you that second chance to say, hey, this is a big change. Are you sure? Yes, I'm sure. And we can make those rename changes. So this is another great thing to do. Use those logging informational messages to try to help us identify what that method was called originally. Okay? Now, As you go through and start to understand what's going on, you're going to have all these renamed variables, and the code's going to start making more sense to you. So if we go back to this d.java here, I'm going to slide this down. This class A synchronizes on the dev urandom object, reads some data, and then, so here's the file input stream. It's doing an input stream. It's returning a data input stream from that open file object, and it's returning that. So looking at that, I think that this A method here is something more like return random file object handle. Okay. Now by renaming that, then later instances will also be renamed. So now I think, okay, this A looks like it's going to be refactor rename the output of return random file object handle. So I'm going to call this random file object handle. As you go through and start making more and more of these changes, the code starts to make a lot more sense. Does it take a lot of time? Yes, it does. You start small and you take breaks frequently, but as you go through, you can build your skills to turning that code into something that makes a lot more sense. As you start making little changes, those little changes give you more and more information, and you start making bigger and bigger refactor rename changes in the app to understand what's really going on behind the scenes. You just repeat this process. The things that I'm showing you here are the things that I apply every time I'm dealing with an application that's been obfuscated. You apply them a little bit at a time, and as you do that, you gain more and more understanding of the application. Now, so far, we've been talking about some basic obfuscators like ProGuard. There's also a commercial version of ProGuard called DexGuard, but there's other commercial obfuscators like DexProtector as well. These more commercial obfuscators will do things like actually encrypting strings. Now, if it's encrypting a string, it has to decrypt the string for the application to run, which means the key is in the obfuscated code somewhere. It's our job to then try to understand where that code actually exists. Other things that obfuscators do that are more complicated are add empty instructions. Add a whole bunch of code to the application that does nothing to the actual application, but it ties you up in trying to understand what the code does to slow down your analysis or maybe try to get you to give up on your analysis. So there are other tools that we can use to help us even more with some of this de-obfuscation. So if we go back to the digital wallet application here, oh no, we're going to look at a different application. I'm going to close this. I'm going to look at another application I wrote called Secure Notepad. And if I run Secure Notepad and I open it up just to show you in Jadx GUI, we're going to look at com.willhackforsushi Secure Notepad, the D class here. And if we look at this application, we see more evidence of obfuscation, these weird byte arrays with a bunch of numbers, and I'm not really sure what those are. We see the variables have all been renamed, okay? And then we see code that looks like this, and we could spend a lot of time analyzing that code to try to find out what's going on. But there's another tool I want to talk to you about called Simplify. Now, Simplify is a tool written by Caleb Fenton, which is wonderful. It's an open source tool, and it includes a lot of really great functionality. Okay. There's Simplify by Caleb Fenton. What Simplify does is it takes an Android application and it actually executes small portions of the code, not looking to de-obfuscate by manually static reverse engineering, but by saying, okay, when I execute the code, I saw that when I ran these 14 instructions, nothing really happened. I think those are dead instructions that don't do anything, so I'm just going to remove them from the output so now you don't have to analyze it. Now, unfortunately, Simplify does not run well on Windows. I've been talking to Caleb about this, and I'm not sure why it's not working quite yet. So I always switch to a Mac or to Linux. It does work fine on Mac or Linux, but just not on Windows for some reason. So I'm going to switch to my terminal on my Mac here. And what I'm going to do is I'm going to run Simplify, and I'm going to read from the Secure Notepad APK. Now you could just run simplify.jar and then the APK file, and what Simplify will do is execute every instruction in that app and then analyze it, try to de-obfuscate it, and then spit out a smaller, more legible binary. The problem with that is that it's really super slow. So I'll typically not run Simplify for the entire application. I'll specify -it for include type, and I'll specify a class that I want to de-obfuscate. In this case, com will hack for sushi, secure notepad d, semicolon dash greater than, which means only that class, not all the other classes that call that class. Okay, so only that class itself. So I'm going to run this, and it will take a minute here to finish up here. Oh, really quick, okay? And what it does is it says in the output is optimized by it made constant a bunch of things that were constants, not variables. It removed dead assignments. It removed dead results. It did a whole bunch of other optimizations here, or tried to where available. And in the output, it writes out a secure notepad _ simple APK. So that is the version of the APK that I now want to analyze. So what I'm going to do is I'm going to run Jadx GUI again. I'm going to open the simplified version of Secure Notepad. I'm going to put this on the left. I'm going to get this version over here on the right so we can see both. And I'm going to go to this same method, com.willhack for sushi. Oops, D is what I want. Okay. Now notice how Simplify does not rename variables for us. Simplify still has A, B, C, D, E, F, G. It still has these byte strings and everything. And that is still going to be your responsibility as an analyst to figure out what those things mean. But look at things like this. A whole bunch of code is now missing from the simplified version because it did nothing. It wasn't used, and so the simplified version has removed all of that functionality that you don't need to look at. This function here returned a Boolean value. Okay, this is the same function on this side. So notice, if I line these up, this is the A method in the prior to simplify. This is the A method after simplify. Notice how simplify removed about 8 different lines of code because it was there just to trip up the developer. It doesn't actually do anything. It just makes it harder to understand what's going on. Instead, we get a much simpler version of the application. Look at this down here. This is the original A method, which declared an A string of A within A within A within A, which is a new string of A. It did that for A2, for B2, then it did the log, and then it returned the string. Well, Simplify said, that's a lot of baloney, and it changed it to this. Now, I know exactly what that string is that's being returned, where on the prior to Simplify version, it was this big mess over here. Simplify is not perfect. It will crap out on some APKs. It will hang in some cases, particularly commercial obfuscators are designed specifically to make simplifying not work because they know that's what people are doing. But it does give us a lot of capability, and it simplifies the job of analysis tremendously here, making the job a lot easier to analyze. Of course, from here, I would then export all of this code with Jadx, import it into Android Studio, and apply all the same techniques that we've already looked at, but now I have a much simplified version of the APK to analyze. Okay, so we look at simplify, okay. So I'm running up just at the end of the time that I had allocated today, but I wanted to take this opportunity to talk about these tools and to show you the capabilities and the things that you could do as analysts. An obfuscated APK file is definitely harder to reverse engineer, but we can use tools like Android Studio, we can use Jadx, tools like Simplify, and then our own time, patience, and creativity to turn that obfuscated application back into something that's meaningful that we can understand from an analysis perspective. Now, tools like Dex Protector or DexGuard, they do make obfuscation a lot harder to go through. Just to show you, do I have enough time? Well, just to show you this here, if I run I'm going to run Jadx, I'm going to run the output, and I'm going to give this other app I have that was obfuscated with Dex Protector. Okay. Now I'm going to go into the DexP directory, and like I'm missing classes. All I have is this library. Commercial obfuscators will go to a lot more lengths. So for example here, if I look at the Android manifest file, the entry point to the application has been hidden in com.google.android.gms.ads.purchase.application. Commercial obfuscators will go to a lot more trouble to make it harder to reverse engineer, but we still use the same techniques. Look at the Android manifest file, recreate the code with Jadx, import it into Android Studio. You are going to have to then decrypt stuff, so you're going to have to figure out how encryption works, find the key where it's hidden, then maybe write a little code to decrypt and turn it into something that's more meaningful to you. But it's all certainly within the realm of reason for somebody doing this kind of application analysis. Guys, that's really all I have time for today. Just check to see if there's any questions. I didn't see any questions typed in here. I hope you guys got something out of the content today. If you have any questions, certainly enter it into the message window right there. SANS going to record this webcast. I find that sometimes going through and kind of slowing down the demos, maybe even doing it on your own. If you're interested in any of the applications that I've talked about today, if I can share them with you, I will, meaning if they're commercial or they're not mine to share, I can't. But if they're mine, I'm happy to send them to you to walk through on your own so you can build some experiences as well. And then use that to build up your own skills with Android application analysis. Well, ladies and gentlemen, thank you very much for attending the webcast today. I'd like to thank SANS for the opportunity to share this information with you guys, and thank you to Carol for getting this all set up with me and moderating the webcast for us today. My name is Joshua Wright. My email address is josh@wright.net. If you guys have any questions or comments, you can reach me there or at Josh Wright on Twitter, and I hope to hear from you guys soon. Until then, thank you very much for your time. Take care of yourselves and have fun out there.
All right, and thank you so much, Josh, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, you can visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.